So we are going to start with the first type of decay, which is the alpha decay. So under the alpha decay, when an atom decays by emitting an alpha particle, it changes into an atom of an element which is 2 places earlier in the periodic table. So when an atom decays by emitting an alpha particle, it changes into an atom of an element which is 2 places earlier in the periodic table. And the mass of the atom reduces by 4, and the atomic number reduces by 2. Then the atom that emits the radiation is called the parent nuclide, while the resulting atom is called the daughter nuclide. So under the alpha decay, we can actually say when an atom decays by emitting an alpha particle, it changes into an atom of an element which is 2 places earlier in the periodic table. So when an atom decays by emitting alpha particle, you can find this element sorry, not you can find this element, but it changes into an element, it changes into an atom of an element which is 2 places earlier in the periodic table. So you are going to find it where it is 2 places earlier in the periodic table. That's where you're going to find that element. And when the alpha particles are emitted, the mass number will reduce by 4. So the mass number of the atom, the mass number reduces by 4, and the atomic number reduces by 2. Then we have also said that the atom that emits radiation is referred to as so the parent nuclide is the atom that emits the radiation. So this emits radiation. Then the daughter nuclide is the resulting nuclide that is produced. So the daughter nuclide is the resulting atom. And under the alpha decay, we can actually write down our general equation. So we can write down the nuclear equation. And for the general nuclear radiation, so if you have this element, you have been given as the element which has the symbol of X, and the mass number is A and the atomic number is Z. So this is going to produce a daughter nuclide which is going to have the symbol of Y, and we actually said that the mass number will reduce by 4. So we can actually say the mass number there is going to be A minus 4, and the atomic number is going to reduce by 2, so we're going to have Z minus 2. So that's going to be the daughter nuclide. Then you must also add the helium nuclide, and we said that the notation of the alpha radiation is represented by the helium nuclide. So as you can see from the helium there, that means that 4 is going to be lost and 2 is going to be lost from the atomic number. So under the alpha decay, let us look at an example. So the question reads, uranium 238 is an alpha particle emitter. Using the periodic table, find the isotope into which it decays. So we can first of all write the symbol of uranium. So uranium has a symbol of U, and the mass number we have been given as 238. And if you check on the periodic table, the atomic number, the proton number of uranium is 92. So we have 92 there. So this is going to produce. So in our nuclear equation, we actually say that the new daughter nuclide that is going to be produced is its mass number is going to reduce by 4. So we can actually just write it here, and we can say 238 minus 4. We can also say 92 minus 2. So this will produce Y 234 and 90. And if you check this element on the periodic table, you have to check this element that has the mass number of 234 and the atomic number of 90. You are going to discover that it is thorium. So that's going to be the daughter nuclide is going to be thorium. So we're going to write the symbol of thorium, and we have already written our mass number. Our mass number is going to be 234, and the atomic number is going to be 90. Then plus our helium atom. So this is how the alpha particle decay is going to look at, and we have actually said that the isotope in which it's going to decay is thorium. So we can actually write down thorium 234. So where you have questions, make sure I ask in the group what we have done today. Thank you very much.